This is Celia Cano with Marine Technology TV, and I'm here today with Henry Robinson, CEO of Dynautics. Henry, thank you for being here today.
You're very welcome. It's lovely to be here.
To get us started, can you just provide a brief overview of your career and your professional background for us?
Sure. Yeah, I graduated in physics from Oxford uh, many years ago. Um, and after that, I worked in the silicon chip industry. I worked in the hands-on and device physics for CCD imager fabrication. And then I went on to UCL to do a PhD in electronic engineering. Then, after a brief stint at the Defence Research Agency, I joined Vosper Thornycroft, worked in the controls division, before starting what now has become Dynautics.
That's fantastic. Can you tell us a little bit about Dynautics, how the company was founded, so what your inspiration was at the time, and then, any significant achievements that have occurred since founding?
Yeah, sure. Dynautics was founded under a different name, but it was the same company in 1996. I was working on control systems at the time, and I perceived that there was a need for a ship simulator to support the development of control systems. And so I started Dynautics and I wrote some software for simulating ships. And this led to the development not just of the simulator, but I started using it to develop new control algorithms. And that then grew also into the underwater domain, because at that time in the late 90s, there were something like 300 different tethered underwater vehicles. And there were about half a dozen AUVs. And it's not difficult to see that that's the way the world is going, and people were going to want to cut the tether and start operating autonomously. So I came up with an architecture which facilitated putting control systems on underwater vehicles. Underwater vehicles are very different from surface because not only do they move in 6 dimensions, including rotation, but whereas ships tend to be long and thin and they've got propulsors and steering at one end, underwater vehicles are very varied. So there are torpedo types, there are work class ROVs, there are inspection class ROVs. All sorts of different problems arise underwater, and you're moving in a much more complex way, and you've got buoyancy control as well. So I devised an architecture which would lend itself to be so versatile that you could control a torpedo or a work class ROV all from the same autopilot. So it was the core of an enabling technology. And that's been at the core of our business ever since.
Fantastic. And you touched on marine autonomy, which I'm going to run back to later for quite a few questions. But in the meantime, if you could touch a little bit more on, any challenges that you or the company has faced over the years, and how have you overcome these?
The challenges have been very exciting, actually. Technology has moved so fast over the last 25, 30 years. Looking back to the earliest examples of what we did, our first autopilots were based on processor boards with running DOS. Do you remember the DOS operating system from Microsoft? It's a long time ago, and it seems like a different era. But that's where we started. And in the years since then, technology has moved so fast. We are now designing and building our own ARM processor-based boards, and we're coding to bare metal. So the underlying technology has changed, and it's now possible to build things on a much smaller format with huge amounts of power, processing power, in a very small envelope. And it's a challenge because you're given the choice. You stick with what you know and you wither and die, or you embrace the new technologies and take advantage of all those amazing things that are coming on the stream all the time.
Absolutely. And I can only imagine how much further and quicker things are going to continue into the future. And I'm sure that's something that you've considered as well.
Yeah, things are moving in different directions. So that those challenges were very much to do with the underlying operating systems and hardware. But now we're looking at AI, we're looking at new firmware and software developments. And that's incredibly exciting as well.
Fantastic. And so I want to look a little bit at the technology specifically, and I want to start with the Phantom 2 underwater vehicle. Can you provide just a brief overview of its specs?
Yeah, it's Phantom 2 is designed to operate in within first 100 meters. There are a lot of AUVs which go very, very deep and so on. But when you go deep, you need to build a stronger hull. You tend to need a smaller diameter. The bigger the diameter, the more difficult it is to go very, very deep and maintain the strength that's necessary at those depths. So it's designed to be very versatile and carry a wide range of payloads within the first 100 meters. So little operations and coastal and continental shelf. But at the same time, it's designed to be as versatile as possible. So we started off, if I can put it very crudely, it's like a pickup truck. We've got a control system and a navigation system and a big, big space, and you can put whatever instruments you want into that space. And then we've got a little bit of dry space at the front. You can put electronics into a pressure housing, but you can put sonars and other instruments into the payload bay, which is in the center, and that's free flooding. So yeah, very versatile pickup truck of the underwater world.
Awesome. I love that analogy. And you kind of started to touch on this a little bit, but just to kind of follow up, in an industry that, like you've said as well, is rapidly moving towards autonomous solutions, what makes the Phantom 2 stand out amongst other options?
I think mainly it's versatility. We started with a spec from a customer, and they actually gave us a very loose spec. We might want to do this. We might want to do that. We're not sure. So we had to keep it very, very versatile. So, for example, we've got connectors. So you've got Ethernet power and serial and CAN bus and so on, all available in case the customer changes his mind. So he can put side scan sonar, video, whatever you like onto it. So it really, a very, very important part of it is that versatility. Now, there are some other aspects which we designed into it, which I think give it a little bit of an edge. So, for example, most AUVs, when they've done their thing, they come to the surface, they sit flat on the water. And it makes them quite difficult to spot. But we've designed this thing so that it sits nose up in the water. So it sits pointing up at about 60 degrees. And that means that any buoyancy, which brings it to the surface, maximizes its emergence just in the nose, all in one place. So we've got antennas that can broach the surface, which means we can download the data, we can send it a new mission, and send it on its way. So you can put it in the water in the morning and conduct a lot of missions, and mission after mission after mission without taking it out of the water. The rapid turnaround, which is really important in many applications.
Fantastic. And so looking, a little bit further, what industry or customers is the Phantom 2 best suited for? Who are you, discussing the Phantom 2 with?
Well, I can't really go into the details of our clients, but broadly, the initial client who's sponsored or pressed the big green button for us to go ahead with this is looking at things on the seabed. So side scan sonar and video. But it's got wider applications than that because of the versatility. It can also, for example, be used as a communications hub. So it lends itself to swarming applications. People can come to us with their instruments, and we'll gladly find a way to put it on and put it through its paces.
And are there any recent projects, that the Phantom 2 has completed that you're able to touch on or just share a little bit about?
Well, Phantom 2 has only just got into the water. So it's been at the forefront of our R&D program for the last year or so. So it's a bit early to say, okay, we've achieved all these missions. What we've done is we've put it through its maneuvering trials, and we've taken it out to sea and proved it in a real environment. And over the coming months, we'll be putting it back, and we'll be putting side-scan sonar on it and gathering some data. And I'm hoping we'll have some really good data to show at the exhibitions coming up next year.
Great. And I wanted to look at some of your other technologies as well. So you mentioned autopilot technology earlier on. And so I
Mm.
was wondering if you touch on the autopilot technology, and then I also was reading about your AUV simulator. So if you could just touch a little bit on both of those, how they were designed, what makes them unique, things like that, that'd be awesome.
Yes, as I mentioned earlier, the simulators, sorry, the autopilots around an architecture which is very versatile. It lends itself. Some of these, a simple boat will have propulsion and steering, maybe two machinery channels. But some of the underwater vehicles we've controlled have upwards of a dozen different actuators. So buoyancy, trim tanks, vertical thrusters, horizontal thrusters, and so on. So it's got a large number of channels and a huge amount of configurability. So any channel can be configured to steer, differential thrust, or whatever it might be. So we're controlling all these different axes at once. The simulators are absolutely fundamental. We started off with simulation of ships and simulation of AUVs, and it's an enabling technology. If you don't have a simulator, it's going to be very difficult to build a controller, test it, and put it into the water and have any hope of success. So with the simulators, we're simulating not just the physics of the movement of the vehicle, but we're also looking at the sensor data, the errors on the sensor data, the offsets, and so on, the rate at which you get sensor data, possibly failures, and you can explore redundancy and resilience in the control system. So it enables you to do a complete sea trial, many complete sea trials, before you've even gone and launched the vehicle. So you can test everything. You can tune to a large degree, you can tune the control system, but you can also test what it does when things go wrong. Because it's one thing to build something which works on a sunny day, but to have something which still works and still comes back to you, even when the chips are down, even when everything possible is against you. And sometimes some days it feels like that. Having that degree of resilience is important. And we're able to test that on a simulator. So both the ship and AUV simulators are absolutely fundamental to what we do.
That's great. And so one of my last questions here is, going back to industry trends, you mentioned artificial intelligence, we've touched on marine autonomy. So how have these trends, if at all, I'm sure they have, but how have they impacted and influenced Dynautics in terms of your technology, in terms of your clients, really anything at all as a company? How have you seen these trends impacting you?
Wow, that's a huge question. It's been impacting us for a long, long time. Neural networks have been around for a little while. I remember back in the late 90s, I actually wrote my first neural network program, actually coded all the neuron layers and so on by hand. Nowadays, the technology's moved on so far with NVIDIA chips and so on that these things are interpreting images, and I'm sure you've seen this kind of thing all around us now. So it's moved so fast, but it's also so complex that it's impossible for one person or one small company to span everything from right down from the neural network layers right up to the software that runs on it. That's just too much. So we have to make use of some of these advances that have been made. So you can find ready-made neural networks, and you can retrain them to solve new tasks. So for image processing and so on. But there are some applications which haven't really seen a lot of publicity yet. So, for example, we're looking at using AI neural network technology to enhance our simulators. So we can learn by data logging at high rate. We can get a lot of data on the movements of a vessel or a submarine vehicle, and we can train a neural network to replicate that. So we can use AI for simulation. We can also use that same AI technology to learn how to drive it. So instead of a conventionally designed control system, we can, in the coming years, I think you're going to be seeing some AI-based control algorithms, and it's already happened to some degree. But I think that's quite an important part of our future.
Fantastic. And you kind of started to touch on my last question here, which was just, is there anything that you guys are working on that you can let us know about, or just, what's upcoming and exciting for Dynautics?
Yeah, there's always more. So we've got horizons next year, in 5 years' time, and I have a view of where we want to be in say 10, 20 years at a time, if I'm still around then. It's really exciting, but I don't want to steal our thunder yet. So watch this space.